my voice?
Sir,
Okay.
so
Yes.
Friday class will be maintained like 3 to 5, is it?
Again. Yes. Tuesday will
Yes.
maintain as it is.
No, Friday.
Okay. All right. So I've sent the detail in the. Sorry. Where is?
No, I'm writing down now. Monday
Yeah.
10 to 12, Tuesday 12 to
Yes.
2, Thursday 4 to 6, and Friday maintained to 3 to 5.
You go and see the text. Just type in the text column there. Okay. Yeah.
Okay.
All right. So okay. So for today, let me know if you're not able to see anything on your screen and you're not hearing any voice from me. Okay, so just wave. So anyway, just I'm trying out a new technology for this module. So basically, yeah, so you experience something new in your learning experience. So just to summarize what we learned in the previous class, we have shown you one theorem. The first theorem, what I mean by theorem? Theorem means the truth or something that you know. For example, you know gravity, a law of gravity, but theorem is something that you know 1 + 1 = 2. Right? Theorem is something that you know is true, going to happen. So in the previous class, we learned one theorem. So as you can see here, you see the red dot here. So the red dot here is reaching one number, and this number is I label as blue line, and this blue line is one value. The value is L. Okay, value is L, and this graph is y versus n, the number of n here, number of x. So x here. So as you can see here, this set of data is convergent. Okay, this set of data is convergent, and we try to plot all our data in this case, you see y = fx. This one, y = fx means that we take our data and write it in the function form. Okay, and write in the function form. So as you can see here, but anyway, if you plot the data in the graph, you will see that this data is convergent. Okay, you see this data is a convergent. Again, if you don't understand what is convergent, divergent, we go back to the Moodle, and there's a video link there. So go and listen back in the previous lecture. Okay. So this is how we write a mathematical model. So for theorem one, what I mean by theorem one, or the truth number one, if your function with the infinity limit, right? If you have a function fx or a set of data that you plot in a function fx, and this data no matter go up or go down, at the end you see this set of data will stabilize at one number. In this case, the number is L. So you write your L there. Okay, you write your L there. So if you see this kind of information, you see the L, something limit infinity equal to L, it means that this is a convergent data or convergent sequence. Okay, all right. So we can write Fn equal to An, and just a reminder, the An here is a sequence notation. Remember previous lecture we mentioned that when we mentioned about sequence, we have three different form. That means that we can write sequence in three different ways. So this is one of the way. Okay. So if you follow along the previous lecture, we have three form. We have a red color form, brown color form, and a green color form. So this is the brown color form. Okay, brown color form. Right. So if you combine this statement, you can say that your sequence with the limit from n to infinity, it will equal to L. So it means, what does it mean? If you want to say that the data or the sequence, this is actually what you learned in the previous class. This is standard presentation. If you want to say that the data or the sequence is convergent, you can write in this form. You can write an with the limit from n to infinity equal to L. If your data showing if you n continue to the infinity, you are near to one number, then you can write in this form. Nizam, any question?
No, sir.
Okay, good. Shakil, any question?
No, sir.
Okay. Edmund, any question?
No, sir.
Okay. Let me see. There's one more in our class. Who is it right here? Let me see. Okay, Samandari Supan, for record, he's still not in the class. And just take note, all these lectures are recorded. Okay. Okay. Now, today I want to learn about the property of a convergence sequence. Okay. Start to bring back what we learned in the previous class. Previous class, we mentioned what is convergent. We mentioned what is sequence. Now you combine these two words, convergent and sequence. So, if you see the A with the curly bracket, it means a sequence. So you have the first set of the sequence, AN, and the second set of the sequence, AN with the curly bracket means second sequence. So sequence A, sequence B, or first sequence or second sequence are convergent. If these two are convergent, we can use this equation, or you can use this operation. What does it mean? If you want to use this law, right? The first law is called sum law because it's plus addition. So if you want to use this first set of equation, your first sequence and second sequence, or A sequence, B sequence, or data A, data B must be convergent. Then only you can use this one. So if you want to add these two data together, you can write first set of A data plus second B data. Means you can break the notation into limit to infinity AN plus limit to infinity BN. So this basically is the addition concept. The only things that you need to remember is that the two sequence or your data must be convergent. Only convergent, then you can use this law. The second one is the first concept is the first law is sum law or the additional law. The second one, you follow the same logic. If these two sequence, these two data, A and B, they are convergent, and if you are seeing the question asks you to find the differences between sequence A and sequence B, where you can use a bracket like that, then you can break them into individual data minus individual data. Okay, the first one and second one. So this basically is a very basic understanding. You apply the same addition and subtraction concept. So these are the limit law. Now we go for another one. The next one, you learn about addition, subtraction. Now we come into multiplication. So multiplication, if you have multiplication, if you see there's a constant value in front of your data, right? What does this formula mean? It means that you want to multiply or you want to enlarge the data size, or you want to make it smaller. For example, your data is 1, 2, 3, 4, 5, and the C is a constant value. You want to magnify this data, so you can pull the C from inside to outside. Okay, so this is a constant multiplication law. Okay, you can pull the C from inside to outside. Another one, we call it product law. Product law concerns two. If you want to multiply the two set of data, you can see AN plus BN, the second set, this one. You can see the AN plus, not plus, AN multiplied by BN means first set data multiply second data. You can break them into individual and then you multiply them. So means this is the first set of data multiplied by second set of data. Okay, so far multiplication is quite easy. It will be the same as the basic mathematics multiplication procedure. The third one, you need to take care a little bit. The third one will be quotient law or division law. So if you want to take one data divided by one data, or A, in this case, you see the AN divided by BN. So you take first set data divided by second set of data. You can also apply the division concept here. You take the first set of data divided by second set of data. Okay, provided this one is not 0. Okay, provided this set of data is not 0. If it's 0, then you get 0. Okay. Okay. We have clear addition. This one. We have clear addition. Differences. Addition and minus. Right? Positive, plus and minus. Yeah. Any question from the class?
Sir, the multiplication one. What's
This one.
the difference between the constant multiple law and
This one
total
and this
law?
one. Okay.
Yeah.
So if this one is like you have a constant value. Let's say the question asks you to multiply 100, multiply 1000, multiply 2, multiply 3 to make the data become bigger or smaller. For example, your data is 1, 2, 3, 4, 5. Then you are given the instruction to make that thing a little bit bigger. So you multiply, let's say multiply 1, 2, 3, 4, 5, this set of data by 2. So the end result, the first one will be 1 multiplied by 2. The whole set of data will become 1, 2, 3, 4, 5 will become 2, 4, 6, 8, and so on. This is the first one. Do you get the idea?
Okay.
Do you get the idea? The first thing is just to multiply the constant, like usually what you do with multiplication. This one is that if you want to multiply the two set of data, let's say set A 1, 2, 3, 4, 5, set B is 2, 4, 6, 8. So you multiply two set of data, then you use the second equation. So it's a difference between the first one and the second equation. Okay. All right. So any more question? If no question, remember to mute your mic now, because your mic will create some noise to the other student computer. Okay. Then the next one is division. Now we go to the power law. Power law, as you can see from the screen here, if you have your data an power something, in this case we use p to represent the exponential component, you can take the data out and then you multiply by you can power the p number. Okay, so this is how you write lah. Okay, provided your p must be positive number. Okay, so this one must be positive number. What I mean by positive number? More than 0. If this one is 0, what happened to this value? You have something multiplied by 0. What do you get, Shakil?
0.
You have 1000 power 0. What do you get?
Or power 1.
1. So you always get 1. So it must be more than 0. Huh? So it means that if you want to use power law, your power here or exponential number here must be more than 0. And your set of data inside here, your set of data in the process, in your calculation process, must more than 0. It cannot be 0, huh? Because if inside here 0, the whole thing will be 0. So we don't want to get 0. Okay, yeah? So this is how the limitation of the power law. Okay, clear? So we have covered addition, deduction, multiplication, power law, and division. All right. So the next one. Another one theorem is called Squeeze Theorem. Squeeze Theorem, what does it mean? As you can see from the PowerPoint slide here, if you plot y versus n, so as you can see here, how many set of data you have on this graph? How many set of data? Nizam, you want to try answer? How many set of data from this
Yeah, but three.
graph? 3, yeah? Is it 3? Yeah. So you have 3 set of color. So the first one is AN, second set is a red color BN, the third one is the CN, the light blue color. So as you can see here, these 3 set of data, is it convergent or divergent? Shakil.
Convergence, sir.
Convergent, So these 3 set, AN, BN, CN are convergent. So as you can see here, these 3 set of data, it will arrive at one value here. So in the general formula, this value, if you project to the y-axis there, you'll get the L value. Okay. So what I mean by squeeze data? Yeah, we have 3 data there. So what I mean by squeeze theorem? There is an explanation for that. So if the black color, so is the black color AN is smaller than BN, Okay, try to relate the mathematics model and the graph. AN data is smaller than B data. As you can see here, all the red dot is bigger value than the black dot on the screen. Okay, and the data of C data, the light blue, the CN is the highest among B and is bigger than B and A. So, and the n number must more than or equal to the original or initial. N sub 0 means the initial, the starting point of that number. Okay, so in this case, as you can see, what happened to this set of data represented by this mathematical equation. Then we can use this equation. Okay, we can represent the equation. We can say that if we use the limit for set A, as you can see here, set A will arrive at one value L. The L, of course, I'm not drawing the blue straight line in this graph, but if you understand what is convergent, then you understand why your set A will arrive at L. Okay, so this value is L. Okay, it will be the same. You can, at the same time, you can also write your set data C, your sequence C, with the limit n to infinity will also equal to L, because these 2 set of data arrive at L. Then you can predict, okay, you can predict what happened to B data according to Squeeze theorem. You can predict what happened to B according to Squeeze theorem. If B, your data is between A and C, okay, if your data, if the question asks you, you are given a data in the red color, then you are given the pattern of first set and second set. So first set is AN, the black color data. Then the exam question also will give you the C data. Then you ask you to estimate the B data. So if happen to be agree with this theorem, then you can estimate what happened to your B. Okay, so you can write your B will also arrive at L. Okay, now what does it mean? Let's say I give you a set of data. Data A. Try to see whether you understand or not. If the first set of data A, the black dot, arrive at, if you increase the n, if you increase the n up to infinity, the data converge at 5. Converge at 5. So means this point is 5. Then you have the second set of data C, also converge at 5. Then you are given a function, or you're given a third set of data. But this third set of data is between, is meeting this equation, infinity here. Means all the set of data always between A and C. Then can you estimate the L value for B? Just now A is 5. Set C data is 5. And the question asks you to estimate the new set of data. But new set of data is between A and C. So can you estimate what is the value of, what is the sequence will arrive? The value is 5. Make sense to you? So this is according to Squeeze theorem. Squeeze means you compress the data until it reaches a stable point. Okay, remember this one? So this is an important law. All right, so just to remind you, for this module, we have 4 quizzes. Four quizzes means a short question. So I will ask each one of you whether you understand or not. Then if everyone in the class understand, then I will give you a short question, and I treat it as a quiz question. So quiz question is 10 points out of 100 marks for this module. So I won't tell you when I will give you quiz. So I will just give you a surprise, and I'll give you like 5 minutes to solve that question. So this is how quiz question going to do. So we have learned Theorem 1 just now. Now I introduce you second theorem. First theorem is this one. First theorem is that if the data converge, you can write in this form. For example, the red dot data is AN. It arrived at, it converged at L, so you can write in this form. This is the first theorem. Okay, important theorem. Now we go to second theorem. Second theorem tell you if, now recall what is the meaning of the goalpost. You have 2 goalposts between the set A. If the data is always positive, you have the goalpost between the AN, means is always positive. If your data is always positive and is equal to 0, okay, then your data, no matter how you increase the n, if you increase until infinity also, the data will always give you 0. Okay, try to digest a little bit. What does this mathematics mean to you? If the set of data you have a goalpost, the 2 straight line, it means that the data is always positive. And you increase the n. Increase the n up to infinity equal 0. If you increase the n to infinity, you still get 0. And the set of data must be positive. Then you can estimate what is the value of that set of data. That set of data, straight away you can estimate as 0. Okay, so just recap the previous concept. The first one, the Squeeze theorem. The Squeeze theorem, if you're given first set data, second set data, you check the data, and then you're given the third set of data. Let's say you're given the red dot data, the third set, and you check whether the third set is between these 2 or not. If between 2, then you can predict the third set of data, provided the third set, all of the data you're given, set 1, set 2, set 3, they are convergent. Then you can estimate all the data will arrive at, or will stabilize at 1 value L. This is the first concept. Then the second concept is that if you see the double goalpost, you see the double goalpost for the set of data, you know that at the end they will arrive at 0. If you increase the infinity, n equal to infinity, it arrives 0. You know that you don't need to calculate already. You know that the set of data an will equal to 0. Okay, you know that the limit n increase to infinity, an will equal to 0. So this is the second theorem. We have two theorem now. So Theorem 1 and Theorem 2. Now, Theorem 1 is about convergent equation. Second one, the theorem with the goalpost. Let's look at this example. Okay. Now, find the value of this sequence. Find the value of this sequence. So you know that you are given one formula, n divided by n plus 1, and you increase the limit from somewhere n to infinity. So how do you solve this question? This will be a short question, and it can be appeared in your test 1 and even your final exam. So how do you answer this kind of question? So the first steps to answer this kind of question, you look for the highest power of n in denominator. So just if you look at the question itself, your denominator, the highest power of n is what? Is 1. If you look at this one, a plus n, all right? Denominator is the below one. N, what is the n power? Is n power 1 plus 1. So the first one you check is the power of n in the denominator. In this case, you get n power 1. You divide the denominator and divide the numerator and denominator. So how do we do it? So you rewrite the question, n divided by n plus 1 from the limit to infinity. You divide the numerator and denominator. So you divide with n. Okay? You divide with n because the first step is that you find what is your maximum power or exponential of your n. In this case, you have 1n. So if first set you get n power 2, then you divide by n power 2. The whole equation you divide n power 2. In this case, the whole equation n divided by n plus 1. On the top there, n you divided by n. Below n plus 1, the whole set you divide by n plus 1. So that's why this one will become 1. Okay, the n here, the n become 1 because you divide by n. Then the below one, how you get 1? It because n plus 1, the first n there, you divide by n, you get 1. And 1 divided by n, you get 1 divided by n. Any question? Any one of you don't understand how to get this equation?
So can you repeat that again? The part where you get the numerator.
This one. This one.
Yeah.
Okay. So do you understand what is the n that you need to use? The first thing, you go for the below one, you check for the n power. In this case, your n power is 1. Okay, you get n power 1 is n. So basically, you divide the whole equation with n. On the top, you divide it by n, you get 1. Right, n, the top is n, right? So n divided by n, you get 1. Do you agree? Is it Shakir that you asked question just now?
Yes.
So you understand 1. Then all the entity below here, you also divided by n. So n plus 1, the first one is n, right? N divided by n, you get 1. Plus 1 divided by n, you get this one. Means the top and bottom every entity that you see also divided by n. The whole thing you divided by n.
So
Okay.
okay. So in case like the n is another
So let's say this one, yeah.
yeah, let's say now the number has a power like n of
Power 2. Let's say n power 2. The whole set on the top and bottom also divide by n power 2.
Okay.
Okay. So first step easy. You must find what is the highest n that you have. Look at the bottom and find what is the n power. So in this case, our n power is 1. So the second step is just that you take this one, n power 1 is 1. So n power 1 is n, not 1. N power 1 is n. So the whole set, the top and bottom, you go and divide by n. So that's why you get 1 divided by 1 plus 1 over n. Edmund, you okay?
Yes, sir.
Okay, good. Now we start to use the law that we learned just now. Okay, now use the limit law for sequence. It means this is the multiplication law. Means that you put this limitation on the top and bottom, right? So you can multiply this one in here. So it means that you use the limit law that we learned just now. You have addition, multiplication, division, and all this. So how you write this one into this one is just that you import your limit to the top, limit to this one. This one actually is 1 plus this one, but you know that you have an addition, so you can break them into limit 1 plus limit 1 over n. Okay, so you write this one to this one. So to solve this kind of question, what you need to do, you go look at the bottom there. You have a division, right? So look at the bottom there, denominator, check the n highest power. Then after that, the second step is that to divide the whole equation with the n power. After that, you use limit law to transfer the limit into the top and bottom. In this case, you transfer limit to 1 and limit 1 plus 1. So what does it mean? Why this one 1 plus 1 over n become this one? So we are referring to this law. Okay, you're referring to no. We are referring to this law. Okay, so at the bottom there you get limit first set plus second set. That's why you can write limit first set plus limit second set. So that's why you see this one in the example just now. That's why you see this one will become this one. Okay, get the idea? This one become this one by using limit law. Then the next step is just use your simple logic. What happens if this is the 1 is the number, 1 is the constant, you cannot change it already. No matter how you change the n for the first one, you see the first one on the top, limit 1, if you increase the n to infinity, you still get 1. Okay, then you do the calculation for the first one. On the bottom one, limit 1 n to infinity, you still get 1. And interesting is this one. You have 1 over n. 1 over n, you increase the n to infinity. What is the number or what is the value that you are close at the end of the infinity? You'll get 0. Okay, now how do you get to this conclusion? How you get 0? 1 over n, you can try. 1 divided by 1, you get 1. You increase the n. 1 divided by 10, you get 0.1. You increase the n. 1 divided by 1000, you get 0.001. 1 divided by 1 million, you get 0.50 and then 1. You increase up to a very, very big number. billions or something, increase to infinity, this number you're going to near to 0. That's why you can write this number. That's why this equation become this one. Any question from here to here?
No, sir.
Yeah, make sure you clear, make sure you understand before you move forward, because you're going to snowball to the next topic. Make sure you understand what is happening on the screen. Okay, once you mathematics is once you understand it, you no matter how you change the question, you still understand. Okay, so you do the mathematics. 1 divided by 1, you get 1. The answer for this set of question, if asked you to find n divided by n with the limit n to infinity, the answer is that this set of data, this set of sequence, it will converge at 1. Okay? It means if you do the calculation and you plot the number into the graph, eventually it will stabilize at 1 if you increase the n to infinity. Okay, now just to short note now, just a note. What is the objective or what is the main trick of this kind of steps? Is that we don't want, in this question you see n divided by n plus 1, we want to reduce the equation n divided by n plus 1. We don't want to see unknown on the top. Means we always want to change the top to something, to one number, or we want to reduce the number of n inside the equation. Okay, I'll give you another example. So example number 5. He asks you, is the sequence A converge or diverge? Now this kind of question from this kind of equation, it's very hard for us to guess whether it converge or diverge. Our objective is to reduce the n inside the equation. So repeat what you learned just now in example 4. The first step is to look at the denominator, the bottom one, and then you look at the n. What is the n maximum power? What do you think? What is the maximum power of n? What is the maximum power for the n? Nizam?
Answer?
What is the maximum power of n that you want to choose to divide this equation? You look at the denominator, the bottom one. What is the n power?
It's actually root of n.
Okay, root of n, but it's below denominator. So what happened to your power? How you write something 1 over square root something in the exponential form? N power what? You know that square root
N
is
power,
half, right?
Yeah.
What is the exponential is below the denominator? You divide with something. What happened to your denominator?
So it will be n over 2, is it?
No. So you need to recall your mathematics skill in rewriting this one. You divide with something. Square root is 10 power 1 over 2, right? Is something 1 over 2, right? This one?
Yeah.
So if you look at the denominator, sorry. Yeah. So if you look at the denominator, the highest power is in this case we use 1. Okay, in this case we use 1. So you divide the whole equation with n. You'll get this one. Okay, you look at n, n power 1, right? N power 1. So you divide the whole set of equation with n. So the top one, n divided by n, you get 1. 10 divided by n, and then you put into the square root, you get n squared, right? Because you divide the whole, this one, the bottom one with n, and then you pull the n into the square there. You have to increase the exponential. Okay, so 10 divided by n squared. Do you get that, Nizam?
No, sir.
No. Okay. Okay. Let me try to. You see my mouse, right? Okay. Let me try if the. Okay. Okay, I can't get my pen working. So what I'm explaining just now is that if you divided by n, right? You divided by n here. Do you? Okay, let me try to. Okay, let me start with the. Okay, I try to write something. Okay, right over here. So let's say you want. Okay, give me some time to. Let me do some setting. Okay, hold on. Okay, let me bring out the. Okay. 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 Let me try. Give me 5 minutes. Huh? Okay, my writing pad is not with me now. Okay, what I'm saying that is that if you divide this one with n, sorry. Okay, you can see my mouse at my back, right? So if you divide this one with n, divide this one with n, you are dividing with the square root. You cannot like if you want to bring your n into this head, you have to write n squared. Means this one, if you divide this one with n, if you bring the cap down, you are dividing with n squared. You see? Okay, let me switch screen. Okay. Nizam, you don't understand from here to here, right? You see my mouse? This one to this one? Nizam?
Yeah, this one I understand. The right side.
You understand this one, right? Okay. So I'm trying to explain how to get here to here. So you understand how to get 1, right?
Yeah, the one I understand.
You understand why 10 is divided by n squared or not? You don't understand.
Why is it n square? Because of the root there, is it?
Okay. So you see this one as two things. So the first one you divided by n, right? Then the second thing is the whole bottom you divided by n, correct?
Yeah.
But you want to bring inside the cap. The bottom n here must square, right?
Oh, so okay. So that
So
means
at the
it's
end you
already
still get
calculated for n already.
Yeah. So at the end you still get n square, right? At the end you still the whole equation you still divided by n. So you just pull the cap down, so that's why you get n square. Then this one n divided by n square. That's why you get 1 over n here. Do you get it?
Yeah.
Or still not get it? Do you get it? No.
I think like you put n square because like
So
you want the n product to still be n to the power of 1 because the n is in the square root, but you still want the result to be n. So it's like what times the square root rather to get n to the power of 1.
You are dividing by n, right? So like this one. I put over here. You're actually doing this operation. So you take this one divided by n. So how you rewrite the whole equation? You just take the whole thing will equal to this one, the whole thing, 10 plus n divided by n squared. Right? Do you understand? From here to here, right? This one to this one. Nizam, you see the logic? This one to this one.
Ah,
Then you can break into two operation inside the square root already. So what you do, you just break into two lah. So you can break into 10 divided by n squared plus
and then plus n
divided by n squared.
n square. So when you divide by, I mean like times.
Yeah, then you simplify lah. You simplify, you get this one.
So n is 1, n square is n. Okay.
Okay, so yeah, so again, I expect you to have this kind of skill when you come to mathematics 2. Okay, so if you need time to process, then need more practice on the mathematics. Okay, yeah. Okay, let's go a little bit more, then we can go for a short break. All right, so because it's 4 o'clock already. So again, the first step is that you go and look at the n. So show whether you're seeing the. You're seeing the whole screen, right? Okay. So okay. So I will show you how to make this calculation here. So you can arrive from the left to right hand side. Then after that, you use the limit law. What I mean by limit law is that you pull the limit into top and bottom. You get this one, right? So you use the limit law. You know that the n, the top one will always be a constant, right? So what about the bottom? If you increase the infinity, what happened to this number? You just look at the bottom, this one. If you increase the n, what happened to this number? It will near to what number? Shakir? 10 divided by n squared, and the n is increasing to infinity. What number that you think it will stabilize? At one number, what is that number?
0.
0, correct. Plus 1 over n, same concept. You increase the n up to infinity, you get 0. Square root of 0, you get 0. You take something divided by 0, what do you get? You get 0, right? This whole thing will get 0, right? 1 divided by 0, what do you get? Infinity. 1 divided by 0, you get infinity. What mean by the convergent and divergent concept? What mean by infinity? It means this set of data is converge or diverge, Dizam? Converge or diverge?
Diverge.
Diverge, The answer is diverge because
Infinity, because infinity.
you cannot get one number. You cannot arrive at one number. So you arrive at infinity because the number keep increasing. So the answer for this example 5 is divergent.
Divergent.
Okay, yeah. So the answer for this one is divergent. Okay, so you write your answer like this, the yellow color one. Okay, yeah. Just a short note for those watch on the YouTube. So you can fast forward to a little bit while I'm looking for my writing pad just now. Okay, you can fast forward just for the record. Okay, I end my recording here. We go for a 5 minutes break. Okay.